Okay, hello Cantonian students of all years. This one is just a standard lesson on skills and reading graphs, and it's applicable to everyone, so it applies to everyone, whether you're in year 7 or year 10. So we're going to do this together. So you can see it's week 7, reading and interpreting graphs. We've got your keywords, axis, correlation, and data. And then I've got a bit of a do now activity just to get your brains warmed up. See if you can remember some of this. I mean, some of you may have to do a bit of a Google research, but it's fine. Okay, so you're going to press pause and just try and complete questions 1 to 3, and if you can, the challenge question. Okay? Okay then, so if I just reveal the answers. So if we just look at the first one, name the planets in order from the sun. So I'm going to use my very easy method, just speeds up naming. And then planets, it used to be Pluto, but we don't have Pluto anymore, so I'm going to cross that one off. So M, so you've got two M's. This is the only place you can make a mistake, really. So you've got Mercury comes first. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. That's the order of the planets. You're going to need to know that, okay? So you may as well learn it. Write the word equation for photosynthesis. Again, this is a really common question that comes up. We've got carbon dioxide plus water, you've got some sun energy coming onto the plant, and then you've got oxygen and glucose as a byproduct it releases from the plant, okay? So that's the word equation. I don't want to spend too long on the starter. Draw a dot and cross electron configuration for lithium and chlorine. Now, I haven't got a periodic table on me, so I've given you the atomic number and the mass number there. So from this, you should see that 3 is the small number. So that's the number of protons or electrons. So we've got 3 electrons. 2 can fit in the inner shell. So we've got 1, 2, and then just 1 on the outer shell then. So that's going to be 2, 1. And then if we move over to the chlorine, it's got 17 as the small number. That's the atomic number, which is the number of protons or electrons. And then we've got 2 on the inner shell, and then hopefully you should remember, if you've done this, it's 8 on the next shells. So we've filled up, and you go around the clock. You do the Lahan method. You go 12 o'clock. So you go on the clock, quarter past, half past, quarter to, and then you go back around. Try not to get confused with this. If you haven't done it, just don't worry about it. I'll probably do a video on it anyway. But as you can see, it's got 17 electrons. So we've got 2 on the inner shell, 8 on the next shell, and then 7 on the next shell there. So I've forgotten to write, the electron configuration would be 2, 8, 7. And then your challenge question, can you think of a set of data that would need to be represented by a bar chart? Well, we're going to have categories. It's called categoric data. So things like if you're measuring hair color or eye color or shoe size, anything with a distinct category, that it can't be point something. So if you're dealing with numbers, you can have, if you were measuring my height or my weight, you could have, my height would be around 1.5 meters, but then you could be more accurate and you could say 1.52 meters or 1.523. And you can keep, it's called continuous data. You can keep going and going, but you can't do that with colors. It's either red or white. So if you're measuring the number of cars that pass by in a minute, or the number of white cars compared to yellow, it's going to be a bar chart. You're going to represent that with either white or yellow. And remember, the bars don't touch. But today we're going to be concentrating on line graphs. So your learning objectives really from today is to interpret a range of line graphs in order to determine the relationship between independent and dependent variables. Now we're going to do a bit of a recap on variables, but we got your keywords there, and this is linked to your Unit 7. Everyone's going to be doing one of these eventually, so this is why it's just really good to deliver to all years. So your recap on variables, we're just going to go over this. Your independent, your IV, is something that you change. So the investigator would choose to change this thing. The dependent is the thing that we're measuring. So if I'm changing something, I'm going to be measuring something that's affected by the thing I'm changing. And then you've got some control variables, things we need to keep the same in order to make it a fair test. Otherwise, it's pointless doing it, okay? Now, today, we're not going to be dealing so much with the control variables. It's the independent and the dependent variables we really need to be targeting. So here's a bit of practice, just to recap what we've been doing with variables. So how many sweets can you eat in 60 seconds? So I'm choosing 60 seconds. So I'm choosing, so that's going to be my independent variable because I choose the time here. I'm saying, look, how many sweets can you eat in 60 seconds? So I'm choosing the 60 seconds. What am I measuring? What's my dependent variable? It's the number of sweets. Let's see how many sweets you can eat in 60 seconds. Hopefully not that many, okay? How long does it take you to eat 20 sweets? So I flipped it there. I've chosen now the number of 20 sweets. I said, look, I'm gonna say 20 sweets. How long, which is the thing I'm measuring now, I'm measuring time, is it gonna take you to eat those 20 sweets? So again, you can press pause here, just test yourself, see if you got it. If you haven't, leave a comment or submit some feedback. How many socks can you put on in 30 seconds? Try and identify what you're changing, your IV, and what you're measuring. Okay, hopefully you can see the answers now. And you can see that how many socks is the thing that I'm measuring. So it's my dependent variable. I want to see how many socks I can get on in 30 seconds, the thing that I choose. So time is the IV there. And then for a control variable, not that it matters in this case, but I've said the same type of sock, okay? You, again, leave a comment if you think you can, if you can think of more. So this is the real thing we want to get onto now, the variables in graphs. And there's a couple of tricks here that you can, that if you listen, that it will get you marks. I promise you it'll gain you marks in your exam. So variables in graphs, your independent variable will always be on the bottom of a graph. And I'll show you what that looks like now. And your dependent variable will always be on the side of a graph. Brilliant. Control variables, we haven't got to worry about. So we're just dealing with independent and your dependent. The thing that you're changing on the bottom against the thing that you're measuring on the side. So let's do some practice here. So as you can see, not going to spend a lot of time on this. The bottom of my graph is time, so that's my IV, and the side of my graph on the side is force, which is my dependent, the thing that I'm measuring, okay? Let's do that over here. Let's move over. On the bottom, what have I got? Temperature. So I'm going to just write temperature in there. Try not to press any buttons. Temperature in degrees Celsius. And what was on the side? Time. Really, really useful in an exam. Press pause, try and do this. Hopefully you get it right. How'd you do? Good, hopefully. So you can see my IV is on the bottom, my mass and my DV is on the side, time. Quick tip, it's useful to always put the units. Get into the habit, if there's units, always write them with it. Because again, it's probably worth a mark or two. And those marks mean everything in an exam. It's the difference. It is really the difference between a C and a B or a D and a C. It really is. Okay, let's push on to the next bit now then. There's six relationships to learn. So what have we done? We've done a bit of a recap on variables. We know how to identify now different variables on graphs. But now comes the real lesson, interpreting the relationships. So what type of relationship have these graphs got? There's 6 to learn, and again, you need to know them. So the first one, I've lost my axes here. Let me just do a set of axes a bit quick with a ruler and a pencil. I don't know why that happened. Oh, I gotta press pause then. It's fine, everything's good. Right, X, Y. So I want to draw a graph now. As X increases, as X goes up, so this is X and this is Y. This is your X axis, this is your Y axis. So let's take the example. I've got time against, I don't know, distance, okay? I want to see how far I can run in 60 seconds, okay? Not very far, probably, unless there's some chocolate at the end. Right, so I'm also going to put now, just there. So this is going to be time, and this is going to be distance. And this is measured in meters, this is measured in seconds. I'm getting into the habit of just doing units all the time. As X increases, so as this goes up, this y is also going to go up at a steady rate. And I'll tell you what I'll show you what this looks like. It's a nice straight line, okay? As this gets bigger, this gets bigger. For example, if this was 1, 2, 3, 1, 2, 3, you can see at 1 here, at 1 second, my distance would be 1 meter, but at 2 seconds, my distance would be 2 meters. So as my time increases, my distance is always increasing. And it's a steady rate, okay? It's a nice straight line. This line is nice and straight. Let's have a look at a one then. As x increases, so it's always going to start with as x increases. So this is your x, this is your y. Y is going to decrease now. It's going to get smaller. What does that look like? I'll show you now with a nice line. Okay, it's going to go down that way. So as x gets bigger, so this is still getting 1, 2, 3. You can see it's still going that way. Y is actually coming down now. It's getting smaller. So if this was 8 up here and this was, I don't know, 7 there, the scale's terrible, sorry. But you can see at 1 second, if we're dealing with time here, okay, I've got 8 meters. But at 2 seconds, I've got 7 meters. So the meters is getting smaller now, but time is getting bigger. And it's a steady rate because it's a straight line. Okay, so as x increases, so as this gets bigger now, y increases, but it's an increasing rate. So it's getting faster and faster and faster. And that looks like this. Just like that, okay? So you can see as this gets bigger, this is also getting bigger, but at a quicker rate. Quick tip here, if it's an increasing rate, it's generally going to go off the chart. I'll show you what I mean now, because the next one is also an increasing rate. But that's what this curve looks like. Let's do another one in blue, because you can get, you know, different rates. Let's go over now. So as x increases, y decreases at an increasing rate. Gets confusing, I know, but these are the terms that you have to know. So as x increases, so as x gets bigger, y gets smaller at an increasing rate. This looks like this. You can see that this is going to come off the chart. Increasing rate is going to come off the graph. And you can see that y is actually getting smaller at an increasing rate. It's getting faster. It's going to come off the chart. Last two then, as x increases, so this is x, it's going to get bigger. Y increases again at a decreasing rate this time. This looks like this. Now this will carry on the chart, on the graph, for ages. Okay, it'll always remain because it's a decreasing rate. The other one went off the graph, didn't it? But this one doesn't. This one will stay on. One more to learn. We've got as x increases, as this gets bigger, y decreases at a decreasing rate. This one looks like this. This one looks like this. And again, you can see that this will carry on for ages. Okay, it'll just stay on the graph. So this one gets smaller, this one gets bigger. It always starts with as x increases. I'd recommend, if you're not getting this now, go back maybe 5 minutes and listen to me go on about them again. Hopefully I haven't confused you, but we'll have a bit of a practice now to see if you can get it. Let's draw some in. So we'll go like that, we'll go like that, we'll go like that, and like that. See how you do on these. Press pause and see if you can get it. Okay then, let's see how you did. So first mistake I made, I didn't put the X's and the Y's in when you paused the video, but I've added them in now. And I've rushed the right in, so sorry about this. So the first one, as X increases, okay, Y also increases, and it's a steady rate, it's a straight line. Okay, you could have got that from this was the first example we did. Let's have a look at the next one. As x increases, and it's always going to start with x increases, you can see now it's coming off the chart. This line is going to come off. It's going to cross through this. So it's going to be an increasing rate. But is it decreasing or increasing? Well, y is now getting smaller. So as x increases, y decreases, but it's an increase in rate. It's going to come off the chart there. What about this one? As x increases, y is going up, so it's also increasing at an increasing rate. Again, it's going to come off the chart if I did that properly. Okay, kind of looks like a bit of it's going back on itself there, but that's not going to happen. And then the next one, then the last one, as x increases, y decreases, is going down, at a steady rate. It's a nice straight line. So we're going to go for a quick quiz now, trying to keep this as similar as we can to normal lessons. Oh, I've forgotten to, let me just do the relationship of the graph here. Hang on, let's do this properly. Okay, let's do it. Tidy, tidy, tidy. Now instead of an x and a y now, I'm going to put time here in seconds, and maybe zoom in your distance in meters here. Okay. So try and answer these 3 questions, press pause, and we'll be back in a sec. All right, so we're going to try and keep this as similar as we can to normal lessons. I'm going to give you a quick quiz now before your final task or assignment, whatever we want to call it. Your quick quiz, you've got 3 questions, press pause, see if you can answer these. Off you go. Okay, what investigators call the variable that they measure, the thing they measure is called the dependent variable. I've put dv. Okay, where on the graph would you find this variable? We'd find it on the side of a graph. Describe the relationship of the graph below. Well, instead of an x and a y now, I've got time and distance. And I should have wrote that really, but I didn't. So I've got as x increases, which would be the time. X is the time. As time increases, and then distance increases at a decreasing rate. So my mistake there. Sorry, first video and all. Okay, so here's your assignment. You can either complete this in a Word document, or you can put it on a piece of paper, take a photograph and upload it, but the work needs to be submitted. For each graph, you can identify the variables, so things we've been doing in the lesson today, and we need you to state the relationship in each graph. There are 4 graphs. I'll do the first one with you. There's also a worksheet that's going to be attached, but you just may as well watch the video, get the questions from the video, jot it down, take a photo, and submit there. Okay, that's what I would do. That's probably the quickest way to do it. So let's have a go. So graph 1. Identify the independent variable for a mark. So where's the independent variable? It is on the bottom. So it's going to be time. And I'm also going to put seconds because I'm used to writing the units. It's going to get me marks. Identify the dependent variable. Where do I find the dependent variable? On the side. So it's going to be the distance. Distance. What's that measuring? Meters. Describe the relationship. Now then, this is what we've been practicing. This looks to me like a straight line. So it's going to be a steady rate. Is it as x increases, y is also increasing. So as time increases, distance is increasing at a steady rate. Let's write that down. So what was it? Time and distance. As time increases, distance also increases at a steady rate. Yeah, that gets me 2 marks, see? In maths, you would say that's a positive correlation, but we've got to be careful in science. We've got to identify, because it's worth 2 marks. So you have to put as time increases, distance increases. That's going to get you 1 mark. And then by saying it's a steady rate, it gets you another mark then, or any of the others, increasing rate or decreasing rate, depending on that graph. I've also given you a challenge here. What is the value for each square on the x-axis? Well, this is the x-axis. It looks to me like each square is worth 1, because 2 squares is worth 2. So I'm going to say it's 1. And what's my time measuring? Seconds. So 1 second. Fancy that. What is the value for each square on the y-axis? Well, my y-axis is distance. That's meters. Now it looks to me every 2 squares is 1 here. So every 1 square is going to be 0.5 meters. 0.5 meters. What is the distance at 4 seconds? How do I do that? Well, let's look at 4 seconds. I draw a line up. What's my distance? Look at that. 2 meters. 2 meters. Brilliant. Okay. Here's your next question. You need to submit. Here's your third question. You need to submit. And here's your fourth. By all means, pause away, rewatch the video. If you like listening to my voice or looking at my face, watch as many times as you want. Give us a like and a thumbs up and a subscribe and all the other shout outs that you usually do on YouTube. And I better check on my kids because they've been watching TV for the last half hour.